You can use an analog multimeter set to the resistance scale to get a verification that a capacitor is working. I think this is kind of interesting because you get a gut intuitive feel for watching the charging mode of the capacitor itself. So here's a circuit board from a 1973 era jukebox console from Seeburg. And here's a capacitor we're going to test. Note that I've clipped off one end of the capacitor, in this case the positive side, from the circuit board, so we're testing it out of circuit. We have the ohm meter set to one of the resistance scales, and now we just connect up the test lead, and we can watch as the resistance starts initially at 0, and as it's charging, it's increasing its resistance. And if you wait long enough, it goes off to infinity. Now, of course, a larger capacitor takes a longer time to charge. A smaller capacitor will charge quickly. And depending on which resistance scale you use, you've got another combination of voltmeter resistance and voltage going through here. If you want to repeat the cycle, we can see this is asymptotically going towards a high resistance. You can just short out the capacitor and oops, here we go. Watch it go through that process again. If we put this on a different resistance scale, over here R times 100, and do this, we can see that the charging goes much faster. Right, and in fact on this R times 1 scale, it goes so fast that you really can't see that charging action. Right, so over here at R times 10,000, you'll see that happen. Now, if you do this and the capacitor doesn't charge at all, it just stays over at stays at 0. It's a shorted capacitor. Or if it shows some fixed resistance, then you know the capacitor is also shorted somehow, right? But here, if we get this charging action, this gives you some confidence that it works. Now, you could, if you're clever, use a stopwatch and compute something here with the RC circuit. You could do that sort of thing, but probably easier to use some sort of a digital capacitance tester that'll actually give you the microfarads and farads, millifarads number of that capacitor itself. But this is, I find this interesting because you get this feel for the natural log curve of how a capacitor charges.